Starting with the application overview, we have the front end, the middle tier, and the back end. The front end is made up of React components, Redux for state management, React Router for navigation, Bootstrap and ScrollMagic for responsiveness, Formic manages inputs, React Toastify and React icons round out the user interface. We then use Axios to interface with our middle tier, which is a REST API that was developed using Node.js and Express to perform CRUD operations. Mongoose is then used for object data modeling for the backend, which is a MongoDB Atlas cloud database. The front-end architecture starts with a Heroku entry point. From here, you gain access to the application and the React components. The persistent components include the navigation bar, header, and footer. React Router is then used to provide routes to the home, accounts, user data, deposits, and withdrawal pages. We have partial components on the accounts page to create an account, log in, or change your password. And on the user data page, we have partials for our transaction history and to delete the user. In our header component, we have partials for the current user as well as logging out. And finally, we have the currency exchange rates and currency calculator partial components also going to the header component. Redux is used for state management across all the aforementioned React components. For our user interface, we pulled in packages from Bootstrap as well as ScrollMagic. The emphasis was on a mobile-first and responsive design. Bootstrap cards were used throughout the application, ScrollMagic for animations. For some real-world application, we use Axios to pull in exchange rate data from the CoinGecko API. The user can then use a real currency calculator with Formic managing its inputs. The first authentication challenge was how to store the password securely. We could hash the password, but a hacker could use a rainbow table attack. Instead, we pull in bcrypt to salt the password and stop the attack. We then hash our salted password and store it in our encrypted database. The hacker could then try a brute force search attack. Bcrypt provides a blowfish cipher to slow the hacker down. Our users' passwords are salted, hashed, and then stored in our encrypted database so that they can have a secure transaction. Sorry, Mr. Hacker. The next authentication challenge was how to keep users logged in across the different pages. Using cookies, the user logs in, server creates a session, responds with a session ID, browser stores it as a cookie, which it uses for future requests, server will check the session, and then send its response. For multiple servers, we use JSON Web Tokens. User logs in, server creates a JSON Web Token, responds with a token, browser saves it locally for future requests, then any server can validate and refresh the token and send its response. Thank you for checking out my video and visiting the MIT Exchange.